Today, we're going to take a look at how the Wallaroo platform enables the migration of my agentic AI workloads from GPU technologies like NVIDIA to AMD's ROCm. Starting off in whatever programming environment I'm using to test out these models, I go ahead and import my Wallaroo SDK and then create a client connection to my Wallaroo instance. From there, I can take the first step, which is uploading my model for packaging. And so I use my upload model function that we have here. I give the model a name. In this case, we're dealing with Llama 3 170 billion, so I'll call it that. And then I specify the path to my model artifacts. This is the files zipped up straight from Hugging Face. And then tell Wallaroo this is going to use the VLLM framework. And using this framework allows me to specify all of the VLLM configuration options I'm used to. This includes things like GPU memory utilization, model context length, and KV cache options, as I see here, but can also be included to any of the other configurations I commonly use with VLLM. Next, I can specify the acceleration, which to start off with is CUDA, and the architecture, which we'll have as x86. Wallaroo will then use this to automatically package for the given configuration, the given acceleration, and the given architecture. And in just a couple of minutes, I have my model ready to be deployed. Part of the beauty of packaging this with Wallaroo is knowing that all of the dependencies are taken care of and are automatically included based on what I specify. And this means that it's really easy to migrate from something like CUDA to something like ROCm. And so you can see here, in order to do that migration, I call the same upload model function. All of my arguments are exactly the same. The only difference is that I specify ROCm as my acceleration, and that will kick off the same kind of packaging. Wallaroo will know to optimize for ROCm and include any dependencies needed to run with this configuration. And really cutting over my packaging for my model is as simple as that. Now that my model's packaged, I add a couple of optional configurations to it. The first being continuous batching configurations, so that my model is accepting concurrent connections in order to form batches of optimal size for my model. And I add that to my model configuration with the .configure function. And similarly, I also want to enable my model to accept OpenAI endpoint style requests, and I can configure default options for that and apply it with configure in a similar way. Finally, I specify the hardware profile to use for my deployment, including CPUs, memory, and GPUs to be used. And since I specified ROCm acceleration at model packaging time, Wallaroo will ensure that any GPU resources allocated to that model will be AMD GPUs available in my cloud or on-premise instance. Next, I can build my pipeline, add my model to it, and deploy it out with my chosen deployment configuration. And this will kick off the automatic process of standing up my full inference microservice. That includes provisioning and managing the resources allocated across both CPU and GPU hardware specified, and all steps involved from the inference. Standing up an endpoint to hit, taking care of data transfer, load balancing, and actually serving those inferences and returning those requests back. After a couple of minutes, this is fully deployed and in production, and I can see the inference endpoint created for me by Wallaroo. I can use this inference endpoint along with the OpenAI SDK to create an OpenAI object like I'm used to interacting with and get inferences from that endpoint in the same way. Once I've created my pipelines, I can manage and monitor them through the Wallaroo Operations Center dashboard. I can use this to see the pipelines that are deployed, deploy and undeploy them, see the inference endpoint that has been created for me, as well as see things like the version history of the pipeline. Additionally, I can see what traffic looks like through this, including how many requests are being served by this endpoint, what the latency of those requests, things like time to first token and tokens per second look like over time, as well as the actual logs of the inferences themselves, so that I can dig into the inference results that my model is serving. Today, we've seen how the Wallaroo platform enables me to deploy agentic AI workloads from my model development environment, targeting diverse silicon and varying acceleration libraries, which enables a unified experience between providers like NVIDIA's CUDA and AMD's ROCm. This makes migration between the two seamless and allows data scientists to focus on creating the best model possible, knowing that Wallaroo will make sure that they get the most out of their hardware regardless of what underlying architecture is used.